High-level design deep dive using Java introduction. High-level design, HLD, is the process of designing the overall architecture of a software system before implementation. It focuses on system components, scalability, architecture patterns, database design, APIs, distributed systems, performance, reliability. A common interview topic is explain high-level design using Java. This guide explains what HLD is, HLD concepts, Java-based system architecture, scalability strategies, microservices design, caching, messaging systems, database choices, load balancing, security, real-world examples, common mistakes, best practices. This is one of the most important topics for senior backend engineers and software architects. Simple definition. High-level design is designing the overall structure and architecture of a software system before coding begins. It answers questions like, how will services communicate? How will data be stored? How will the system scale? How will failures be handled? How will security work? Goals of high-level design. Good HLD helps systems become scalable, maintainable, fault-tolerant, secure, performant, extensible. Without proper HLD, the systems become tightly coupled, scaling becomes difficult, deployments become risky, performance bottlenecks appear. Core components of high-level design. 1. Client layer. Users interact with the application through check web applications, check mobile applications, check external APIs. Example: browser, mobile app, backend APIs, front-end technologies. Check React, Angular, Vue. 2. API gateway. An API gateway acts as the entry point. Responsibilities: check authentication, check routing, rate limiting, check logging, check request aggregation. Example: client, API gateway, microservices. Popular tools: Spring Cloud Gateway, Spring Cloud Gateway, NGINX. 3. Backend services. Business logic is handled by backend services. Java technologies: Spring Boot, Micronaut, Quarkus. Example services: check user service, check order service, check payment service, check notification service. Example: REST controller, request mapping orders, public class order controller. Get mapping @/id, public order get order at path variable long id, return order service get order id. Stores application data. Relational databases: PostgreSQL, PostgreSQL, Postgres, Oracle. No SQL databases: MongoDB, Cassandra, Redis. Example: order service -PostgreSQL database 5. Cache layer. Caching improves performance. Popular caches: check Redis, Hazelcast, Memcached. Example: application down, Redis cache, database. Benefits: click, reduced DB load, faster responses, improved scalability. 6. Message queue. Used for asynchronous communication. Popular tools: Kafka, RabbitMQ, Kafka, ActiveMQ. Example: order service .Kafka event .notification service. Benefits: coupling, async processing, scalability. Monolith versus microservices. Monolithic architecture. Single deployable application. Front-end, single back-end application, single database. Advantages: X, simple deployment. X, easier for small teams. Disadvantages: NOC, hard to scale independently. Slower deployments. Tightly coupled modules. Microservices architecture. Application split into multiple services. Client, API gateway, user service, order service, payment service. Advantages: independent scaling, independent deployment, independent fault isolation. Disadvantages: negative distributed complexity, network communication overhead, scalability and high-level design, horizontal scaling. Adding more servers. Server 1, Server 2, Server 3. Best 4. Cloud-native applications, microservices. Vertical scaling, increasing server resources. Example: more RAM, more CPU. Limitation: XX hardware limits. Load balancing. Load balancers distribute traffic. Users dash load balancer dash multiple application servers. Popular tools: NGINX, HA proxy, AWS ALB. Benefits: high availability, better traffic distribution, fault tolerance. Database design strategies, SQL databases. Best 4. Transactions, consistency, relational data. Example: users, orders, payments, NoSQL databases. Best 4. Massive scale, flexible schema, high write throughput. Example: check activity feeds, check logs, analytics. Database scaling techniques, read replicas, primary DB, read replicas. Benefits: check, offload read traffic. Sharding, split data across databases. Example: user IDs 1 to 1M means shard 1. User IDs 1M to 2M means shard 2. Benefits: large-scale scalability. Caching strategies, cache aside pattern. Flow: check cache, miss, read database, update cache. Common in Java backend systems. Event-driven architecture. Systems communicate using events. Example: payment completed, Kafka topic, email service, analytics service. Benefits: loose coupling, asynchronous processing, scalability. Security in HLD. Important areas: secrets, authorization, encryption, API security, secrets management. Java technologies: CAPS, Spring Security, CAPS, OAuth 2, CAPS, JWT. Example: JWT flow. Client login, JWT token generated. Client sends JWT. API validates token. API design best practices, REST API principles. Good APIs should be stateless, versioned, consistent, secure. Example: get API order/1, post API order/1, delete API order/1, fault tolerance. Systems should handle failures gracefully. Techniques: retries, circuit breakers, fallbacks, timeouts. Java tools: CAPL, resilience for J, Spring retry. Example: service A, service B, fails, fallback response, observability and monitoring. Modern systems require monitoring. Important metrics: CPU, API latency, error rate. Tools: X, Prometheus, Grafana, Elk Stack, OpenTelemetry. CI/CD in high-level design. Deployment pipeline. Code, commit. Build, automated tests. Docker build, deploy to Kubernetes. Tools: check, Jenkins, GitHub Actions, Argo CD. Java technologies commonly used in HLD area. Java Technology Backend Framework, Spring Boot, Security, Spring Security, Messaging, Kafka, ORM, Hibernate, API documentation, OpenAPI, Cloud, Spring Cloud, Containerization Docker, Orchestration Kubernetes, Monitoring, Micrometer, Build Tool, Maven, Gradle, Real-world example, e-commerce platform components, client apps, API gateway, user service, product service, order service, payment service, notification service, databases service, database user service, PostgreSQL, product service, MongoDB, order service, PostgreSQL, notification service, Redis, async communication, order created event, Kafka, inventory update, email notification, analytics processing, caching, popular products, Redis cache, common interview questions. 1. How do you scale a Java backend system? Answer: load balancing, caching, horizontal scaling, microservices, database replication, async messaging. 2. Why use Kafka? Benefits: high throughput, event-driven systems, list coupling, async processing. 3. When would you choose microservices? Use microservices when: check, large teams exist, independent deployment is needed. Check, services scale differently, domain boundaries are clear. 4. How do you handle distributed failures? Using: check, retries, circuit breakers, fallbacks, idempotency. Common beginner mistakes. 1. Over-engineering, using microservices too early. 2. Ignoring scalability, single DB bottlenecks appear later. 3. Tight coupling, services become dependent on each other. 4. No monitoring, production debugging becomes difficult. 5. No caching, unnecessary database load increases. Best practices: check, design for scalability, use stateless services, separate concerns properly, use caching strategically, use async processing where appropriate, monitor everything, secure APIs properly, document APIs clearly, avoid distributed transactions when possible, keep services loosely coupled. Sample high-level architecture. Users, load balancer, API gateway. Underlined, user service, order service, payment service. Underlined, PostgreSQL, Oracle, Kafka event bus, notification service, analytics service, final summary. High-level design focuses on building scalable and maintainable software architecture. Key concepts include: microservices, messaging systems, databases, fault tolerance, API design, monitoring, cloud-native architecture. Java is widely used in HLD because of Spring Boot ecosystem, enterprise reliability, scalability support, cloud integration, distributed systems support. Key idea: high-level design transforms business requirements into scalable system architecture, capable of supporting real-world production traffic.